Today we are going to be talking about a pretty simple way of identifying stars, and it is called the HR diagram. And the HR diagram actually stands for two scientists who discovered how to plot and graph stars. A man by the last name of Hertzsprung and a man by the last name of Russell. Now, when looking at the stars in the night sky, they might all look very similar to us, and we might see them as same colors or same brightness. And from Earth, we call that our apparent magnitude. So apparently the star looks white, apparently the star looks very bright, apparently it might be yellow, it might look dim. So they call that apparent magnitude. And back when these two guys were actually trying to plot the stars, they decided that, well, apparent magnitude wasn't going to work. And so they came up with what we call absolute magnitude. The star is absolutely this bright. The star is absolutely red. And so they go through these types or identifications of stars, and they come up with a pretty easy and simple way to plot the stars. And they just called it the HR diagram. So when you look at the HR diagram, we have several categories going on here. First, we have the x-axis down here, which is temperature. But one thing I want you to notice about the x-axis here is look at the arrow. It's pointing the opposite direction of what we're used to a graph going. So in this case, it's basically saying low temperature is over here, so cool, and high temperature is on the left, so hot. So over here we have cool, and over here we have hot. On the y-axis, we have what's called luminosity, or what's simply referred to as your brightness. And it goes from the bottom, which would be considered to be dim, up to the top, which is going to be considered bright. And those are the two bases that they first decided to plot stars by. But then, as time went on, they realized that not every star is the same color. So they added in colors of stars across the top of the graph. We have blue, white, white, yellow, red, orange in color, and of course red. And that's not the only thing that they noticed about stars. Then they started noticing, when looking through telescopes, the stars were different sizes. So in comes a fourth way to plot the stars, which is by their size or category. And they call this spectral class. Spectral class just means where they rank in size. So when you put all four of these things together, temperature, brightness, color, and spectral class, you can then plot all the stars in the universe. Now, I have a few highlighted here, and these are just ones that I wanted to point out to you guys. And I noticed I just forgot to do the very important one, which is right here. This is our sun, and that's its proper name, sun. And scientists base this whole chart on our sun. Because it's the closest to us and it's the easiest one to measure, they take our sun and base the rest of it off of that. Now, I'm going to tell you one thing. If you came across here and you could draw a line, our sun would be about here on the graph. And they consider this to be a brightness of 1. Brightness of 1. So our sun is the basis of all other categories. So if you're below the sun, you're not very bright, you're dim. And if you're above the sun, the star would be very bright. So our sun has a luminosity of 1, or a brightness of 1, and that's what all other stars get based off of. Now, if you look here in the middle of the chart, we have this huge category. And this category is known as main sequence. And most stars are going to spend their life in a main sequence stage. 90% of stars are going to be here. And then you're going to have other stars that go in the other categories. So, we have the category at the top here of supergiants, which then can be broken down into red supergiants, yellow supergiants, white supergiants, and so forth. We have just our giants. We have red, red-orange. And then we have our dwarfs. Our white dwarfs will be at the bottom, and they're going to be less bright. Now, if I said, let's talk about Polaris, which is the North Star. If I said, tell me the brightness of the star Polaris, you would say it's definitely brighter than the sun, and most of the charts are going to have a number here. So you would come across and say it's pretty bright. If I said tell me the color of Polaris, it would be yellow. If I said what class is Polaris or group is it in, well, it's a supergiant. And if I said give me a temperature, I would come down to the bottom and I would find my temperature. Now my graph is more simplified, so I don't have all the numbers across the side and the bottom of the X and Y axis, but HR diagrams do have temperatures where you can look and find the exact number. So let's look at Barnard's star. So here's Barnard's star, and just by looking at it, I can say, okay, Barnard's star is a cool star. It's a dim star. It's a red star, and it is in the spectral class of main sequence. So this chart is actually super easy to use. What if I said, look at Sirius B? Yes, Sirius B, like Sirius Black from Harry Potter. So we have Sirius B. It is a white dwarf. It is white in color. It is dim, but it's getting hot. It's pretty hot. So if I asked you to look at Regulus, here, it's a main sequence star. It is blue-white in color. It is brighter than our sun, and it is hot. So using this chart is actually super simple. And like I said, some of the charts will actually have numbers for brightness on it and numbers for temperature, but for today we went simplified and I don't have those on there. So this is the HR diagram, or what we call the Hertzsprung-Russell diagram, and it is used to plot stars in a graph so that we can measure them and compare them to others. Please remember the words apparent magnitude and absolute magnitude. Apparent is how we see a star from Earth. Apparently it looks red or blue to me. But absolute, it absolutely is red. It absolutely is hot. Okay? All right, that sums up today. Pretty easy, right? Very simple. All right, have a good day.